Unit 6, Section 2, Integration by Substitution. Session objectives. By the end of this session, the student will be able to find integrals by the method of substitution. Integration by substitution. Given the integral of a binomial ax plus b exponent n dx, if n is large, then expanding this binomial becomes tedious, and therefore we resort to what we call integration by substitution. Meaning we let a variable to be the binomial. In this case, we let u to be ax plus b. Then we differentiate u with respect to x, and that gives du over dx, which is equal to a. Now, we make the x the subject, which gives du over dA. Since our binomial is u, then the integral ax plus b power n dx becomes the integral u exponent n times du over a, which gives 1 over a, which is a constant out, that the integral of u exponent n du. Now we integrate u exponent n. Integrating u exponent n gives u exponent n plus 1 divided by n plus 1. Then multiplying 1 over u plus c. Example. Use a suitable substitution to evaluate the following integrals. A. The integral 3x plus 1 into braces power 4 dx. B. The integral, the lower limit -1, the upper limit 1, dx over into braces 2x plus 3 exponent 2. C. The integral, the lower limit 0, upper limit 1, x root 1 minus x dx. D. The integral x squared into braces 2x exponent 3 minus 5 exponent 7 dx. Integration by substitution. Given the integral 3x plus 1 into braces exponent 4 dx, if we want to multiply out the binomial 3x plus 1 4 times, it becomes tedious. So we resort to what we call integration by substitution. And that is, we let a variable, in this case u, to be the binomial 3x plus 1. Then we differentiate u with respect to x, which gives du over dx to be 3. Now, making the x the subject, we have the x to be du over 3, which means our integral u exponent 4 times du over 3, meaning in place of the x, we now write du over 3. And in place of the binomial 3x plus 1, we write u. Now, multiplying u exponent 4 by du over 3 gives u exponent 4 over 3 du. But 1 over 3 is a constant, so we factor it out, which means we have 1 over 3, the integral u exponent 4 du. Now, integrating u exponent 4, we increase the power by 1, dividing by the new power, which gives u exponent 5 divided by 5, then multiplying 1 over 3, which gives u exponent 5 over 15 plus c, or 1 over 15 u exponent 5 plus c. But we know our u is 3x plus 1. And hence, replacing u with 3x plus 1, we have the integral 3x plus 1 into braces exponent 4 dx is equal to 1 over 15 into braces 3x plus 1 exponent 5 plus c. Integration by substitution. B. The integral, the lower limit -1, upper limit 1, then the x over into braces 2x plus 3 exponent 2. Using integration by substitution, we substitute u for 2x plus 3. And differentiating u with respect to x, we have du over dx to be 2. And making the x the subject, we have the x to be du over 2. Now, we change limits. Since the integral will now be in u, the limits must also correspond. So we change limit from x to u. Changing limit from x to u, when x is -1, and putting -1 into 2x plus 3, we have u to be 1. And when x is 1, we have u to be 5. Now we change everything from x to u, which means the integral -1 as the lower limit, upper limit 1, then the x over 2x plus 3 into braces exponent 2 is now equals to our new limits, the lower limit 1, the upper limit 5, the 1 over u exponent 2 times du over 2, which is the same as the dx we made the subject, which equals 1 over 2. Since 1 over 2 is a constant, we bring it out. Then the integral, the lower limit 1, upper limit 5, u exponent -2 du. Now we integrate u exponent -2, which gives u exponent -1 divided by -1. Then that gives -1 over u, multiplying 1 over 2. Now we now put in the limits, then we multiply the result by -1 over 2. Now putting in the limits, in place of u, we put 5. So that gives -1 over 2, the 1 over 5 minus 1 over 1, which is simplified to give 1 over 5 as the answer. C. Giving the integral, the lower limit 0, upper limit 1, x root 1 minus x dx, we integrate this definite integral by integration by substitution. In this case, we let u to be the root of 1 minus x. Now taking square of both sides, we have u squared is equal to 1 minus x. Now we differentiate u squared is equal to 1 minus x in the same way as we did for y exponent n. So this implies that 2u du over dx is equal to -1. And making the x the subject, we have -2u du. And x is equal to 1 minus u squared. Now, since we let u to be the root of 1 minus x, meaning our integral will be in terms of u, and hence the x must be changed to du. So our limits must equally change from x to u. Now changing limits, when x is equal to 0, u is equal to 1. And when x is equal to 1, u is equal to 0, which means that our integral, the lower limit 0, upper limit 1, x, the root of 1 minus x dx, is now equals to the integral, the lower limit 1, upper limit 0, then into braces 1 minus u squared times, in place of dx, we write minus 2u du. Now the negative 2 there is a constant, so we bring it out, so that we have negative 2, the integral 1, 0, u squared minus u power 4 du. That is if you multiply the bracket by u squared. Now integrating u squared minus u power 4, we have negative 2 multiplying 1 over 3 u power 3 minus 1 over 5 u power 5. Then the limits, lower limits 1, upper limit 0. Then putting in the limits, we have negative 2 multiplying 0 in place of u power 3 gives 0. 0 in place of u power 5 gives 0. Hence, when the limit 0 is put in, we have 0. Then we put in 1, which gives 1 over 3 minus 1 over 5, which is simplified and multiplied by negative 2 to give 4 over 15. Integration by substitution. Example D. The integral x squared into braces 2x power 3 minus 5 exponent 7 dx. To evaluate this, we use integration by substitution, and hence letting u to be 2x power 3 minus 5. Now differentiating u with respect to x, our du over dx gives 6x squared. And making the x the subject, we have dx to be du over 6x squared, which implies that our integral x squared into braces 2x power 3 minus 5 power 7 dx equals the integral x squared. In place of the binomial, we write u, so we have u power 7. Then in place of dx, we write the dx in terms of u, which is du over 6x squared, then plus c. Now, multiplying the integrand, we realize that the x squared in the numerator will cancel the x squared in the denominator, which gives 1 over 6 out, since 1 over 6 is a constant. Then the integral u power 7 du. Now integrating u power 7, we have u power 8 divided by 8. Then multiplying the constant plus c, which is the constant of integration. Now we substitute 2x power 3 minus 5 for u. So meaning wherever we have u in our expression above, we put 2x power 3 minus 5. So therefore, the integral of x squared into braces 2x power 3 minus 5 exponent 7 dx is equal to 1 over 48 multiplying into braces 2x power 3 minus 5 exponent 8 plus c, the constant of integration.